like in video number 8, we solved by substitution. So we will use substitution again for this video, but the equations we will be solving are more complex. So I have here two equations. Let's start with this.
Again, how will you know that you will use substitution? Look at the equation first. You must see a connection between this and this. Both of them are powers of 4. So from them, we will get the substitution that we will do to solve for x. Okay, so simplify the left side first. Again, the addition of indices here will tell you that it can be written as 4 to the power of 2x times 4. Then, right side, still that. Still same. Okay. Now, the substitution that we will do becomes much clearer now that we've written it in this form. So, look at these two, 4 to the power of 2x and 4 to the power of x. So, we can simplify further your 4 to the power of 2x as 4 to the power of x squared. Then, times the 4 here equals to, right side is still the same. So, from here, we can clearly see the substitution that we will be using. So, we will be using substitution for 4 to the power of x. Let's use the variable a. Because you have 4 to the power of x in both sides, left and right. So, now the left side will be written as 4a squared, and the right side is 17a minus 15. The result is again a quadratic equation in terms of a. So let's solve the quadratic equation to get the values of a. We have 4a squared minus 17a plus 15 is 0. This time, I will just use the calculator to get the values of a. Mode 5, 3. A is 4. B is negative 17. And C is positive 15. So, the values of A are 3 and 5 over 4. So, A is 3. And also 5 over 4. Now, from here, we solve for the value of x by substituting a with 4 to the power of x. So, that means 4 to the power of x is 3 or 5 over 4. Okay. Again, we use logarithms to solve for x. Logarithms to base 10. So, I'll get, though this side here becomes x times the logarithm of 4 to the base 10 is equal to the logarithm of 3 to the base 10. Let's just put a divider here. And this is x times the logarithm of 4 to the base 10 is equal to the logarithm of 5 over 4 to the base 10. So, the values of x that we will have are these two. And for this one, we have the logarithm of 5 over 4 to the base 10 divided by the logarithm of 4 to the base 10. Then we just use the calculator to evaluate these two. Correct the 3 significant figures. Okay. Let's now move on to the second exponential equation. Again, we will solve by substitution. Where do we get the idea that we will use substitution? From 9 to the power of x and 3 to the power of x plus 1. Okay. For this one, it's more complex to see that substitution has to take place. Unlike in the first one is more obvious because both have base 4. But in here, you have to remember that 9 can be expressed as a power of 3. Then, both of them have powers of x. See? So, because we can express 9 as a power of 3, that's where the idea of substitution comes from. This and that. So, that will be our first step. So, we change 9 to the power of x as a power with base 3. That will give us, so 9 is 3 squared. So instead of 9, we write 3 squared to the power of x. So 9 to the power of x is this now. And then, we can simplify 3 to the power of x plus 1 as 3 to the power of x times 3 plus 27. And then, we can rewrite this as 2 times 3 to the power of x squared. Anyway, they give you the same result, right? 2x, x, 2x also. Why did we do that? So we can see the substitution that we need to do. So, look for the common term in both sides. So, left and right, both have 3 to the power of x. So, we will be using substitution for that. 3 to the power of x will be, let's use the variable a. So, now the left side becomes 2a squared equal to 3a plus 27, which is again a quadratic equation in terms of a, and then we solve for the values of a. So 2a squared minus 3a minus 27 is 0. Using my calculator to get the values of a, so yeah, this time a is 2, b is negative 3, and c is negative 27. So the values of a are 9 over 2 and negative 3. A and 9 over 2. And just like what we did in the first equation, we will replace or substitute a with 3 to the power of x to solve for the values of x. Is 9 over 2. Use logarithms to solve for x from here. So I will have to divide this first. So I'll have x logarithm of 3 to the base 10 is equal to the logarithm of negative 3 to the base 10. Same for this, x times the logarithm of 3 to the base 10 is the logarithm of 9 over 2 to the base 10. So once again, we have two values of x, which are these. And from here, we have over, and just evaluate from your calculator. Correct to 3 significant figures. So that's how we do solving by substitution for exponential equations.